Hi class, let's finish this chapter 2 and look at even more applications. Okay, so we'll really solve two different types of problems in this last section. One that involves what we call price raises or decreases in increments, and as we'll see, it really doesn't have to be just about the price. And one about minimizing inventory costs and production runs cost. Okay, so that's really the same type of problem, but looked at in two different ways. Okay, so let's get started. What does it mean to look at price raises, decreases in increments? So let's read this problem. It says, a hotel can rent all its 300 rooms if it charges $100 a day. For every $10 increase in price, 10 less rooms will be occupied. What should be the price the hotel should be charging in order to maximize revenue? So that's what we're looking at, maximizing revenue. And how many rooms will be rented at this price? So let's see what this story, first of all, is. And by the way, that's kind of what it's going to keep on being for all the other problems. So you have 300 rooms, yes? And you charge 300 rooms. You rent 300 rooms if you charge $100 a room. So you get rid of all. Now, 300 rooms times $100 per room, right? So you're going to make what? $30,000. Yes, great. Now, what it says is, well, obviously, can we charge more? But the thing is, if I'm going to charge $110, right, per room, I'm not going to get all of them occupied. How many will I get occupied? 10 less. So what does it mean, 10 less? Only 290 rooms will be occupied. So, fine, 290 rooms at $110 a room. Let me do the math really quick. On this one's not so easy. But 290 times 110 is 3,900. So really, as you see, you're making a revenue of $31,900. That's more, right? And the question is, how much more can we push these price increases? By the way, fine, it costs more. I am renting less rooms, but I am charging more per room, so I'm still making more money. But the thing is, at some point, when you charge too much, there won't be enough rooms rented, so you end up overall making less revenue. Again, what's revenue? Number of items times price per item, yes? So let's try one more. What if I push it one more time to one more $10 increment, in other words? $120 a room. How many rooms will be occupied? 10 less. It says every time you increase the price by $10, you lose 10 occupants, yes? So one more time, 120 times 280 is going to be 33,600. Ooh, good. So really, if anything, this is also a question of what? Not only, fine, you're making more money, but really you have less rooms to clean and change the sheets and everything. So if we actually putting in the costs involved as well for a total profit, things are going to change a bit. So this is what happens in a problem where we talk about price increases or decreases. By the way, what's going to happen? If I charge less, I'm going to rent more rooms. If I charge less, I'm going to rent more rooms, right? So the cheaper an item is, the more we're going to purchase it. The more expensive the item becomes, the less we're going to purchase it. So the point is they go in opposite directions. More money per item, less items. Less money per item, more items, right? So they will always go in different directions. So this is what we're going to do. The easiest thing to do is we'll call X the number of price increases. So how many times should I push this extra $10, right? Should I push 1 extra $10, 2 extra $10, 10 extra $10. How far should I push it? So the best thing to do would be to call X the number of price increases, where one price increase is a what? It's a $10 price increase. Yes, every $10, right? Okay. So what do we want to do? We want to maximize the revenue. So let's do this again. Not profit, just revenue. So same as we discussed in the last section. How do you make money? Well, you sell some items, in this case, rooms, at a certain price, right? At price per room. Okay, that's it. So, how many rooms are we going to rent? Well, remember, we're starting at 300, but for every $10 price increase, we're going down 10 rooms. So, we're starting at 300, and we have to take what? 10 rooms, 10 rooms. So 10 times X, right? For every one time I go down by 10 rooms, yes? So every one price increase, 10 rooms less. That's why it's multiplied by 10. And it's minus 10 less. What's the price per room? We're starting at $100. And then we go up in price, right? By how much? $10 in every one price increment. So this goes up by 10. This goes down by 10. Okay. So here's your revenue. As you see, is a function of X. We want to maximize it. How do you maximize or minimize anything? Well, you're going to find the derivative and so on and so on. So first thing I'm going to do though is multiply all this out. So 30000 minus 1000x plus 3000x minus 100x squared. Now combine like terms. That's minus 4000x minus, no, I'm sorry, minus and plus, that's plus 2000x. And then minus 100x squared. Great. So this is the revenue that we're supposed to maximize. How do we do that? Again, as I said, we take the derivative, which is what? 2000 minus 200x. Set it equal to 0. And solve for x. So x is going to be 10. Okay. So in other words, if I would have had to do this, I had to do it 10 times until I start losing money. Okay. So there's going to be 10 price increases. Okay. So what should be the price? Then the price per room is going to be, again, remember, we're starting at 100 and we add $10 for every increase, and it's going to be 10 of those. So the price per room is going to be $200. We're going to push it up to $200. Okay. And how many rooms will be rented at this price? So the number of rooms rented at this price will be 300 minus 10 times, we said x was 10, right? So the number of rooms is right here. So that's 100, so that's going to be 200 rooms. So we're going to push 200 rooms at $200 a piece. That's going to make a total of $40,000 in revenue. Okay, so that's just how easy it is. Now, in the textbook, I did show you a different method. I prefer this one much, much more. But there's another method I found in a different book about using slopes. So please read through the book. If that makes more sense to you, perfect. Use that method, but I like this. Okay, so let's try a few more. I have 3 more for you. It says, a dealer can sell 4 cars per day. So that's really like our starting point, right? 300 rooms at $100 a day, and then one goes up and one goes down. Depends how we push it. So it's starting at 4 cars per day at $12,000. For every $200 price reduction, 2 more cars will be sold per day. Okay. If each car costs the dealer $10,000 and fixed costs are 1,000. What price should be charged in order to maximize profit? And how many cars will be sold at this price? So this time, this problem here is just about revenue. Now we are dealing with maximizing profit. What does it mean to maximize profit? Or in other words, what's profit? Profit, first of all, let's write it down. So profit is going to be revenue minus cost. Yes? So we've gone through it. And we want to maximize this profit. Okay. So last problem, we only dealt with revenue. And as you see, there's costs involved here. So let's talk about this. One more time, one thing at a time. How do we make revenue? We're making revenue by selling some items at a certain price. What items are we selling? Number of cars times whatever the price per car is. Okay? Minus what will be our costs? Well, it says it costs the dealer $10,000 for each car, yes? And then there's fixed costs. So we always have, not always, but most of the time when we're talking about costs, we have variable costs and fixed costs, right? So what are cars? What are variable car costs? Now, number of cars times cost per car. So each car costs the dealer a certain amount, yes? And depends on how many cars you're selling, right? But there's that. Plus our fixed cost. Okay. So we've had plenty of cost functions. There was something times x plus a fixed amount, right? That didn't depend on the number of items, but there it is. Okay. Now, I don't see an x, and I'd like to have an x, and I should have started with that. And I'm going to fix it in here. So again, it's a price increase or decrease. In this case, I'm decreasing the price, right? Price reduction. So we're going to call by x the number of price reductions. All right. Okay. So by how much from the 12,000 I go down 200, 200, 200, 200. Every time I go down 200, the number of cars will do what? Will go up, up, up by 2, yes? So now that I have all this, just like the last problem, let's start filling it in. How many cars are we going to be selling? Well, it says 4 cars per day plus 2 more cars every time you decrease the price. So 4 plus 2x, right? Just as here, you started at 300 rooms and you lost 10 rooms every time you increase the price. This time you're going to decrease the price. So 2 more cars, right, for every price reduction. What's the price per car? Well, we're starting at 12,000. And then what happens? Every time we, oops, not plus, but we decrease the price by 200. So we go down in price 200 to 100. Same as the last time, we charged $100, but this time we were increasing the price by 10 every time. Now we're going to be decreasing it, yes? Okay, minus, let's make sure we keep this grouped. How many cars, right? The costs. Now it's about the costs. So how many cars? Well, it's the same amount of cars. It's not an X or anything like that. X is the amount of price reductions, by the way. So it's the same amount of cars that we're talking about. All these cars that we're going to be selling costed the dealer something. Yes? What happened to this light? All these cars we're selling costed the dealer something. Okay? I don't know what happens to this light. It's pretty bright here. Okay, so how much did it, how many cars? Well, it's the same, 4 plus 2x, yes? times, though, what's the cost per car? It costs the dealer $10,000. Doesn't say 10,000 more, 10,000 less. It doesn't matter how much the dealer ends up spending or selling these cars for. That's what he had to purchase it to begin with. He might have had a deal on the other end where he purchased the cars from the manufacturer, but the dealer got them all, got the deal of $10,000 per car. Yes? Okay. Plus, one more thing to add on here, there's fixed costs, right? So the fixed cost to the dealer, no matter how many he'll end up selling, is $1,000. All right, so there you go. This is the function. Let's just put it together. So I'm going to start right here because it's a lot of distributing. So I have 4 times 12,000 is 48,000. Plus 2x times 12,000 is 24,000x. And then 4 times negative 200 is negative 800x. And then 2x times negative 200x is negative 400x squared. And then don't forget this minus. So it's minus 40,000 minus 20,000x and minus the $1,000 fixed cost. So combine all these like terms. This is what I'm getting. I'm getting a negative 400x squared. Then all these x terms put together, that's 4,000 minus 800 is 3,200 x. And the 48,000 minus 40,000, that's 8,000 minus 1,000, that's 7,000. Okay, so we got them all. All right. So here's my profit. We want to maximize it. How do I maximize profit? Well, I'm going to take its derivative and set it equal to 0. So the derivative is negative 800x plus 3,200. Set it equal to 0. Minus that over, divide by 800. It's easy. X is going to come up to be 4. Super easy linear equation. Great. And then what? So I got x is 4, so we know the number of price reductions. So what price should be charged in order to maximize the profit? The price per car is right here. You started at 12,000 and you took down 200. How many times? 4 times, yes? It's all written there. So in other words, you're going to be charging 11,200 per car. Okay. What price? So we did this. Should be charged. How many cars will be sold at this price? The number of cars you'll end up selling is 4 plus 2x. 4 plus 2 times 4 is going to be 12 cars. At 11,200 a car. So, as you see, the problem doesn't ask you to find the maximum profit. If you would have said, then you would have had to plug in that x in here and come up with a maximum profit. But when no one wants to know. Okay, so we got 2 more problems. Okay. So it says, an apple farm yields an average of 30 bushels of apple per tree when 20 trees are planted on 1 acre. Each time 1 more tree is planted, the yield decreases by 1 bushel per tree. How many trees should be planted per acre in order to maximize the yield? So it doesn't have to be about money and prices. It's about the same type of increment. So this is what this story says. You got 1 acre of land and you put some apple trees, yes? A whole bunch of them. And then each tree produces a certain amount of apples. So if you have if you have 20 trees, yes, then each tree will produce 30 bushels, right? Like basically baskets of apple. Okay, but the thing is, every time you add on another tree, the nutrients in the soil will spread out over more trees. So it's gonna be a little bit less that each of the trees is gonna get to produce, right? Because it's gonna get less nutrients, less water, and so on and so on. Less sun maybe, right? It's just these trees start covering each other. So you could push it, but then they won't produce as much each. So how far should we push it is again the question, yes? So here it is. The yield, right? We want to maximize the yield. And again, let X be the number of extra trees, or trees increments, yes? Okay, because it's actually, by the way, one extra tree. So we want to maximize the yield. The yield is the number of bushels, the number of bushels you're going to get. So that's going to be what? Number of trees you have, right? So number of items, which are your trees, times what? How many bushels you're producing per tree. So I don't know if you noticed, but every single time this one's going to cross out the bottom to get you the total amount of bushels, right? Or number of items times price per item. The items go away and you're left with a price, right? With a total amount. So how many trees are we going to be planting? We're starting at 20 and we are adding one more tree. So plus one extra X. How many bushels do we get? Well, we're starting at 30. And every time you get one more tree, you get what? The yield decreases by 1 bushel per tree. Okay, there it is. That's your function. So again, distribute super easy. So the yield, combine like terms, it's going to get you a negative x squared plus 10x and plus 600. Okay. You want to minimize or maximize something, take the derivative. Set it equal to 0 and solve. So this one's going to be a 5. Okay, so you can only push 5 extra trees. Yeah, so how many trees should be planted? Well, 20 plus 1x, it's going to be 25 trees. And that's it. It doesn't say any more. So it says just how many trees should be planted to maximize the yield. 25 trees. That's it. That's your answer. I'm not asking for more, right? How many trees? That's it. By the way, if I was to ask how many bushels will then they each produce? Well, 30 minus 1 times 5, they will each produce 25 bushels per tree for a total of 620 bushels for the total acre, right? That's the yield. Okay. Finally, one more and then we'll take a break. So I'm trying to give you quite plenty of examples on this price increments, decrements, and it doesn't even have to be the price, as you see. Okay. So let's see here. What else? I'm just messing with this light. It's just, even though it's daytime, it's so dark because of all the fires. All right. So what am I going to say? Here it is. There's one more, and there's, as I wanted just to say, there's plenty more examples in your book, by the way. Okay. So when a theater owner charges $10 for admission, there's an average attendance of 90 people. For every 10-cent price increase, there's a loss of 1 customer. What admission should be charged to maximize revenue? So there's no cost involved, as you can see. Nobody talks about the cost. All we want is the revenue. So again, let X be the number of price. What are we doing with the price this time? Increasing or decreasing? Increase. Okay, and we want to maximize the revenue. How do you make revenue? Number of items, in other words, people, times the charge per person, right? So these people go to the movie theater, we're selling tickets, right? So a number of tickets if you want, that's your items, right? Admission tickets. And then what? price per ticket. Yes. Okay, how many people are we starting with? Okay, 90. What happens to the number of people? There's a loss of one customer. Every time we increase the price, we lose one customer. Good. What's the charge? Well, we're starting at $10 per person. And what do we want to do with that $10? We want to increase it by how much? 10 cents. So remember to not write 10, but it's not $10, it's just 10 cents. So that's 0.10x. That's it. So let's just distribute. Easily done. 90 times 10 is 900 plus 9x minus 10x and minus 0.10x squared. There's your revenue. Okay, combine like terms even. I see what happens this time. Okay, how do you maximize revenue? Again, find the derivative. Set it equal to 0. What's going to be the derivative? Is -1 minus 0.20x. Set it equal to 0. This time something funny is going to happen. Okay, throw the 1 over. What I'm showing you is that you're going to end up with a negative. So 1 divided by 0.20, if I'm correct, that should be a 5, yes. But it's a -5. So what does that mean? In fact, if you want to increase revenue, you should have -5 price increases. In other words, what? You should not be increasing the price. You should be, in fact, decreasing the price, right? So you're pushing it the wrong way. Okay, so it says what admission should be charged. So what's going to be the price per person? We have it right here, $10 plus 0.10 times x was -5. So in fact, you shouldn't increase the price, but you should decrease it 10 cents. So $9.50 per ticket. Yes. So you are going the wrong way. Okay, so it works perfectly, right? It tells you even what direction you should be pushing things into. So at $9.50 per ticket, it doesn't ask me, but I'm just going to still tell you how many people will attend. We started at 90, and then -1 times -5. Here, I'll even write it down. So then 95 people will attend. Okay, at $9.50 a ticket, you in fact will make more money. All right, than the 900 that you would have made initially. Okay. So we'll take a break and we'll continue with our last type of problem in the next video.